Bathymetric LiDAR data. Bathymetric LiDAR data is a type of data obtained using LiDAR technology to map the underwater terrain, particularly in shallow waters like coastlines, rivers, and lakes. It utilizes a green laser beam that penetrates the water to measure the distances between the water surface and the seafloor. This data is then used to create detailed bathymetric maps, which are essentially maps of the underwater topography.
So bathymetric LiDAR data is collected using two different lasers. One green laser that penetrates the water and reflects off the seafloor or the riverbed, and then one infrared laser that reflects off of the water surface. And using these two measurements, you can create what is known as a time of flight measurement, and that gives us the depth of the ocean floor. And so the equation for that is going to be the depth equals the speed of light in water times the time delay between the two lasers divided by 2. And you can collect this data either in a plane or a boat. And if you want more detailed data, then the boat is the best option for bathymetric LiDAR.
So bathymetric data is used for a number of things. The first one would be hydrographic surveying and mapping, which is creating nautical maps, studying coral reefs, channels, and like where shipwrecks might be. It's also used for coastal management and engineering, which is understanding like how a coastline might erode, how sediment transports around, and what the coastline might look like. It can also be used by providing accurate information for planning and implementing infrastructure like dams, levees, and coastal defenses. The last thing that we found it could be used for is for environmental purposes, like helping assess the health of coastal ecosystems by providing information on the distribution and condition of aquatic vegetation, coral reefs, and other marine habitats.
An interesting area to use bathymetric LiDAR would be to observe the wave of Nazaré, Portugal. So that is what we chose to do. We used bathymetric LiDAR provided by the European Marine Observation and Data Network to show why the waves at Nazaré, Portugal get so big. This place is known to be one of the largest waves in the world, and it draws in surfers from all over. The waves can reach over 100 feet. The European Marine Observation and Data Network gave us bathymetric LiDAR that exposed a vast, deep submarine trench that reaches depths of over 5,000 meters and stretches roughly 230 kilometers offshore of Portugal. This canyon funnels and focuses waves coming in from the Atlantic, creating a very large wave on the shore. These underwater features have a significant influence on the wave dynamics. As the ocean swell travels across the Atlantic and approaches the Portuguese coast, the Nazaré Canyon acts as a wave energy conduit, focusing and accelerating these swells. The canyon allows waves to maintain more of their deep water energy as they travel towards the shore, whereas in contrast, waves that travel over a flat seabed dissipate their energy more evenly.
In addition, the canyon's shape causes a refraction effect, where wave fronts bend and converge towards a focal point just offshore from Praia do Norte. This convergence results in wave interference, where multiple waves align to produce significantly taller waves through constructive interference. Combined with local wind patterns and swell direction, this bathymetric influence produces some of the largest rideable waves on Earth. The bathymetric scan helps quantify and visualize this dynamic interaction, providing critical insight for surfers, oceanographers, and coastal engineers interested in wave formation and coastal hazards.
Overall, bathymetric LiDAR data really helped us gain insight onto why the waves at Nazaré, Portugal get so big. It was very interesting for us to look into this type of equipment because as people living in Colorado, we do not get to see it up close and personal too often.